So we're continuing where we left off in our last video, where we found our reference points. So we want to think about, we've got an asymptote at -6. Our domain is going to be all real numbers. Our range, because of our asymptote, we're going to have the y values be greater than -6. So asymptote at -6, coordinates at -2, -2, and at -1, 2. So our graph is going to look something like that. So number 5, we're looking at how our coordinates are changing. So our x values will need to subtract 2. Our y values will be multiplying by -3/5 and then adding 3. So the coordinate 0, 1 is going to become -2 and then 12/5. We'll also have a coordinate at 110 because the base of our exponent is 10. And it's going to change to -1, -3. So what else do we know? We know there's an asymptote at 3. Our domain should be all real numbers. And our range, we have not only done a vertical translation, but we've also reflected. So that means our y values will now be less than 3 where our asymptote is. So asymptote at 3, and then coordinates at -2, 12/5, which is going to be just over 2, and at -1, -3. So as we move, it's going to look something like that. So let's say we have the picture. We want to be able to write the function that goes along with it. So they're telling us already what our base is too, so that's helpful. If we can see the vertical asymptote, that's telling us our y value, or our k. So our asymptote, it's a horizontal asymptote. Our asymptote is at y equals 1, so that means k is equal to 1. If you take the first reference point, so that's the point closest to your asymptote, in this case it's -1/3, -1/3, that's showing you where you're shifting left or right. So that tells us that our h value, we're shifting left by 1/3. So the hardest thing now is to find out what our a value is. So taking that reference point that's closest to the asymptote, you take the y value and you say that a plus k is equal to that y value. So we found that k is 1 from our asymptote. So then you would say a plus 1 is equal to -1/3. So solving for a, we get -4/3. So now we have all of our pieces. We know each of our constants are as well as our base. So then you can just plug those into the formula to get your equation. So here we have b is 10. So we can see that the asymptote is at y equals 6, so that means our k value is equal to 6. The first reference point, that's the one closest to your asymptote, is at -4, 4.4. So that tells us our h value where we're shifting left is -4. So then the y value, the y coordinate is at 4.4. That's going to be our a plus k. So a plus k will be 4.4. K we already said was 6. So 4.4 minus 6 would be our a value is -1.6. H is -4 and k is 6. So from there we can plug those into our function. So we will get -1.6, 10 to the x minus -4. Sorry, that should just be x minus 4 because it is minus -4. Sorry, x minus -4 and then plus 6. We're not double checking the other value. We're going to assume that it works. Domain is again all real numbers. Range, we did have a reflection. So our y values will be less than, and then it is whatever our k value is. So in this case, it would be 6. All right, so here we know that b is 2, so our base is 2. First thing we look for is our y asymptote. So we have an asymptote at -5/2. So that means our k value is -5/2. So then we take the point closest to our asymptote. So this tells us that our h value will be 3. And so then we still need to find a. So what we're going to do is we're going to take a plus k, and that should be equal to the y value at that point, which is -1. So plugging in what we have for k, which is -5/2, is equal to -1, we'll find that a is 3/2. So now we can take all of these pieces that we have, plug them into our function. G of x is equal to our a value, 3/2, times our base, which is 2. So we'll have 2 to the x minus 3, because we shifted right 3, and then minus our y asymptote, which is -5/2. So our domain, as always, is all real numbers. Our range is just y greater than our asymptote at -5/2. We can do some modeling. So an exponential growth function has the form f of t is equal to a times 1 plus r to the t, where a is greater than 0, and r is a constant percent increase expressed as a decimal for each unit in time. So most of this is just going to be calculator work, plugging it in and finding the missing pieces. So if we go back to this example, we'll look at it. Tony purchased a rare guitar for 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Use a graph to find the number of years it will take for the value of the guitar to be $60,000. So taking that function, so f of t is equal to the initial value, so 12,000 times 1 plus the percent rate increase, so 1 plus 0.014 to the t. So that's our function. You could use your calculator to graph the function. It says use the graph to predict when the guitar will be worth $60,000. They use the trace feature. You're actually better off just also graphing the line y equals 60,000 and then using intersect. It's going to give you the more accurate answer rather than just using the trace function. So at the same time that Tony bought the $12,000 guitar, he also considered buying another rare guitar for $15,000. Experts estimated that this guitar would increase in value by 9% per year. Determine how many years the two guitars will be worth the same amount. So we take our initial value, 15,000, times 1 plus the increase in rate, so 0.09%. So really we're taking 15,000 times 1.09 to the t. So if you graph the two functions, we're trying to predict when the two guitars will be worth the same amount. Since you're graphing those two functions, you can just set them equal to each other. You want to see where they're the same. So if you do that, you can see they've already graphed it there. The two guitars will be worth the same amount about 4.98 years, or about 5 years after the year 2000. So we're just going to do one more of these. John researches a baseball card and finds it's currently worth $3.25. So that's our initial value, 3.25. However, it's supposed to increase in value by 11% per year. So our rate would be 1 plus 11%, or 1.11 to the t. So in how many years will the card be worth $26? So we're trying to find when f of t is equal to 26. So this is where we'll grab our calculator. We're going to graph two things, 3.25 times 1.11 to the x, because that's our variable. And I'm also going to graph 26. So since I know I'm going to have a line at 26, I'm going to have to change my window here. So I'm going to make it 0 to 30. Oh, just kidding. We'll keep our x values the same. We have to change the y values. We'll change the y values from 0 to 30 with the scale of 3. Hopefully this is happening within 10 years. Otherwise, we'll have to change our x values. Well, it looks like we're going to have to change our x values. So obviously those aren't increasing the same yet. Let's change this. Change this to 30 and this to 3. We'll see they should intersect here. And if you do the intersect function, you'll find that the time is about 20 years.